Okay. Let's get this up. Can everyone hear me? In the back? Cool. Okay. All right, good, Rohit. I'll start.
Go for it.
All right, everyone, welcome to lecture 2. I just wanted to start with some logistics. So some TAs have been receiving DMs on CampusWire, and they've also been receiving personal emails. We please request that you message us, or that you make public or private posts on CampusWire so that we can make things public, and so that you can also get responses as quick as possible. And we're also we're doing this thing where if you don't submit your assignment and it's late, you can still submit it afterward for up to 60%. Rohi, is there a deadline on how long? Whenever?
Yep.
At the end of the course?
Yep.
Great. So even if you haven't done an assignment, you can still submit it for up to 60% of the max score. And I think that's it, right? Is there anything else?
Yeah, just kind of one thing to add on to that though. Do the assignments on time because they are building off of each other, and once you get to the hack challenge, if you're really behind on assignments, it's going to be really hard on your group members. So just keep up with things. Also, you don't want to have to do like 5 assignments at once.
Yeah, so yeah, be reasonable about that. And one other thing, also personal emails, direct them to either the main Cornell email, which is cornellappdev@gmail.com, or the courses. What are the courses email?
CornellAppDevCourses@gmail.com.
Exactly. So either of those two. Also, when you are done with the assignment, we are going to post a feedback form that we'd like if you can fill that out after every lecture and once you've completed the assignment, so that we can keep track of how we're doing, so we can improve on our lectures and assignments. Thanks. All right. So let's get started. First, we're going to do a small review on the concepts from last lecture. So remember the client-server model. You have a client, which can be your phone, your laptop, or whatever. You also have a server, which can be a computer too, running your app.py, like a JavaScript application. And remember that your clients send requests and that the server replies with responses to those requests. So reminder, requests are initiated by clients. They're going to be sent to a specific URL, right? So for your assignment, you send it to your local host, and then there's a path after it, which, for example, it can just be slash, or maybe slash tasks, slash post, right? That's your path. And all of them have methods, so you've been using get and post methods. Get to actually get information from the server, or post to send information to a server to receive a response. And yes, for post request, you need to send a body. You can also send data through a get request by using query parameters, which you can explore more if you do the extra credit. I believe that is tier 3. So for responses, those are always going to be triggered by client requests. So the server will be sending a response, and there will also be a response code associated with a response. So for example, anything that's 200 usually means that it was successful. 201 means you created something. 200 means that it was okay. You can just search those up. You don't need to memorize those. But yeah, 200 means that it's okay. 400 means that there was a server error. 500, well, no, 400 means, yes, that there was an error through the request, right? Maybe something was not found. Maybe you passed in a bad request. 500 usually means that that is an error in the code, and you need to check out your code. And for something more visual, remember that the client will send a request to the server, and then the server will receive that request. There will be some operations inside of the server, and they will respond with a response, which will be sent back to the client. So for today, we're going to be talking about databases, but before, let's talk about data persistence. So say you have this as your dummy database. It's a dictionary. You may have already noticed that there are some issues with using a dictionary for a database. Namely, if you start your server and then you reset it, everything that you put in your database is gone, and that's not great. So there are lots of problems with using dictionary. First off, stopping the server. It also doesn't scale efficiently, and you'll see more why when we actually talk about a database. And there is no enforcement of formatting. So say you want to enforce that something is a specific type. With dictionaries in Python, you can set whatever type, but it'd be nice if you can always guarantee that something is a specific type without having to actually put any additional code for that. So let's talk about databases. A database is a collection of organized information. You can think about it as tables. We'll see a visual representation soon. But a database should be easily accessible. You should be able to access data easily. You should be able to update data as well, and you should also be able to manage the data in your database. And databases are implemented as collections of tables, and we'll see what that means. So picture this. This is a table, and you can picture this as a database. So if you look at each of the columns, we have our IDs, just like how we had in our dictionary. You have a name column, a quantity column, and a price column. These are going to be the specific fields of your object. And then for each row, besides the first one, which are just the headers, each row is an actual object. So the first object with ID 1 is an apple. There's 10 apples, and they cost $1.15. You'll notice that there's always an ID, and that's important because it makes it much easier when we're trying to access data and update data, because there might be a duplicate in the database, and there'd be no way of differentiating that. One important thing to note is just how you did with the assignment, there is incrementer that you need to keep incrementing because everything needs to have a unique ID. And the way to guarantee that is, say I were to delete banana, we don't really know that there's no more ID 3, but we maintain that uniqueness by always using other IDs. So we're never going to need to reuse IDs, we just keep incrementing, and that guarantees that everything is unique. Now, one important distinction. A database is not a table, it's a collection of tables. And what that means is, for example, I wouldn't say that I have a fruit database. I'd say I have a database that has a fruit table and an employee table. And the important distinction there is that you need to notice that each table has its own IDs. Because I couldn't just say, oh, what is ID 1? Is it a fruit or an employee? That would be very ambiguous. This is why a database is a collection of tables, and you have different tables that maintain different things, different representation of objects. So why would we prefer using a table over a dictionary, right? You've already worked with the dictionary. It seems to work fine, but yes, there are issues with it. For example, if you consider the benefits of a database, the data is structured. You have a table, right? And you have each of the fields. You say that you have an ID, you have the name of something. Yes, you can do that with dictionaries too, but it is much more structured with a table. It does scale well because say I want to add a new field to the dictionary, right? Say, I guess if we talk about the Reddit assignment, let's say with posts, I want to add, I guess, can someone come up with an example? I think right now post has links, username, and upvotes. Say I want to add maybe the time it was created, right? I have to go into the dictionary and I have to update everything manually. And that can be a pain. With databases, it's going to be much easier with that. And one of the main benefits of databases is that you can query data. And essentially what that means is that you can ask the database questions, unlike with a dictionary where you need to manually do things. And it's super useful for larger databases, as we'll see in this example. For example, if I want to find out how many fruits are in a database using a JSON file, for example, I would have to open the fruit JSON, and then I'd have to iterate through it by checking, okay, for fruit and data fruits, I'm checking to see the fruit inside of the JSON. And then for that fruit row, I need to look at the quantity and check which ones have more than 0, because we want to see which ones are in stock. And then I would append that to the list, and then I would print that out. Yes, this works, but if you were to use a database and you'd be able to query using a query language, it looked very simple using this language. You want to select the fruit names from the table fruit, and we want to check which ones have a quantity greater than 0. So this is what we would like, and this is going to be very useful when we have larger databases, because it's much simpler. So what exactly is this? This is a structured query language, and maybe you've heard of this as SQL. SQL is going to make our lives much easier, and it is what we're going to also be doing in the demo today. So before I go on, are there any questions? Cool, okay. Don't mind to raise your hand if I'm lecturing. So with a query language, it's essentially a language that helps us communicate with the database, and it helps us create, retrieve, update, and delete data. And that's great because that's what our CRUD routes are for. We're going to be able to use those SQL commands to extract things from routes. So I'm going to present these commands, and I'm going to also associate them to the CRUD routes that you'll be able to use them, and you'll see how those are applied when Robbie puts it up in the demo. So this is the SQL code to actually create a table. Essentially, you have to write create table. You're going to have a table name, say an example fruit, and then you want to put in the columns, which remember those are the fields. So for the fruit, it had a name, it had price and the quantity, and then we want to set the data type. So this is an example. Say you had a user. It has an ID, because everything needs an ID. You'll notice that it's an integer, because it's a number. It's a primary key, and you need to put this for IDs, because we'll get into that in other lectures. That helps you have an identifier for something, and if you want to try to say, oh, maybe I have a fruit, and I need to associate it to something else with a relation, that's what it's used for. So don't worry about that too much. And then you have auto increments, because the ID needs to increment. If you put this keyword, it's going to do that automatically for you, and you don't have to worry about it. For name and age, those are the same. You can say that it's text. Maybe age would be better represented as an integer, but in this case it's a text. And you can also specify that it's not null, because you must specify a name and an age for a user. And then for email, it's just represented as a character string. So that email has a character length of 50. So this is very nice compared to how you have to do it with a dictionary, because you have to actually manually write that code to check whether or not it satisfies these constraints. So this is one of the nice things about SQL. So this is creating a table. If I'm, this specifically we need to do to actually create the database, because we need to have a table to represent our data. So this is essentially, the translation of this would be, instead of using your dictionary, you do this command, and then you have your dictionary ready for you. Now let's say I want to insert data. So this would be post request. This is what you want to do if you're saying trying to create a task or create a post. The way this looks is you want to insert into, put your table name, and then you want your columns. So remember, those are your fields, name, ID, and whatnot. And then you want to specify the values that you want to insert into your table. So one example of this would be if I'm trying to insert into user, name, age, and email, because those are the column names. And then I want to insert these values. I want to insert John into the name, 21 into age, and email. And this should work because John and 21 can be converted into text, as in the other example, and then this is within 50 characters, so this would be accepted. This would be post requests to actually create something. And now we want to talk about our get routes, and you can do this through retrieving data. Pretty simple. All you need to do is select, and then you specify columns you want, and then from table name. So let's say I'm trying to use SQL to make a route that gets all the data. There's a very nice shortcut for this. You can use the asterisk, and this will select all of the columns, and you can use that to easily return all the data you have. But let's say I want to get something with a specific condition, like when I was trying to get the fruit in stock that had a quantity greater than 0. You want to select the columns, you want to specify the table, and then you also want to put the condition. So for example, if I want to select all of the columns, so basically I want to get the ID, name, age, and email of a user, that will give me all of that data, and then I want to get the users that are at least 18. This will give me all of those users, and I can return them. Any questions so far? Cool. And then the last thing is, well, there's two more. This is updating, so this is going to be a post rep as well. To update, you just need to specify the table you want to update with, and then you can set specific columns. So say for column 1, I want to set it to a specific value, column 2, and so on and so forth. And then I can specify the condition of which I want to update. So, for example, let's say I want to update something in the user table, and I want to set the email to jsmith@gmail.com. I want to set that for any entry that has an ID of 1. So this is how you would update a specific value. This is also one reason why identifiers are useful, because if I were to try to update, say, jsmith, there might be multiple jsmiths in the database, and that'd be inconvenient. So the identifier helps us make sure that we're updating one thing. You can also do something where I want to get users greater than 18, although this wouldn't really make sense for that because we should have an email. But you can put whatever condition you want there. And the last thing you need to know for the demo is how to delete data. Pretty simple. All you need to do is delete from the table name, and then you want to specify what exactly you want to delete. Let's say I want to delete something from the users where the ID is 1, then I'm going to delete the user which has the 1 ID associated with it. And yeah, that's about it. Any questions before we begin the demo? Cool. Robbie.
That was fast.
Okay.
Stop over yours. Or no, I don't need a clicker. I'll start recording. Make sure I am in frame. That's exciting.
Whatever.
That's a good question.
Oh man, it's not on.
Oh yeah. There we go. All right, let me turn the mic on. Cool. Y'all can hear? Perfect. So, unlike Gonzalo, I use a Windows computer. So this time we're going to be running Windows commands. If you see something different than last time, do what works on your computer. You should know how to activate a virtual environment if you're using Mac or Linux and how that's different. I'm not super going to go over that again, but you will get to see me activate it on Windows.
If you forget, we're here to help.
Oh yeah, we also have 2 menial labor people to help you out. So use them as you see fit. Cool, so I guess before I got into the code, I wanted to go over a little bit of how you might use SQL commands in an actual shell. For those of you that kind of went through the pre-class to-dos, you will have SQLite installed. If not, you can read, hopefully. I think, is that big enough? Should I make it bigger? Hands up if you want it bigger. Sounds good. Cool. So I will run SQLite 3, and we can see that now I'm in the SQLite shell because it says SQLite at me. Very nice. Cool. So the command to create a table is conveniently create table. And I don't know, let's just make a user table with an ID, right? That's going to be an integer. So you say the name of the field and then the data type. This ID is going to be a specific kind of integer called a primary key. And what the primary key field does is it essentially says, hey,
I will deal with this field for you. You don't have to tell me what this is. I will know that this is important to this value. This is especially important later on when we get into relational databases, but for now, it's just telling SQL, hey, this is how I want to refer to this, this table, elements in this table. We're also going to give it auto increment. What auto increment does is not exactly what it sounds. You might think, oh, it automatically makes the ID go up by 1, and it does. But if you just write primary key, the IDs also go up by 1. The distinction is with primary key, let's say, you added me to the database and then you added Gonzalo to the database. But I might have an ID of 1, Gonzalo might have an ID of 2, right? Now let's delete Gonzalo from the database and add Shungo in. If we add Shungo in, if we keep auto increment, he's going to have an ID of 3, which is what we want. But if we don't have auto increment, it's going to give him an ID of 2, which is confusing because some front-end applications might have stored that Gonzalo's ID was 2. They might try getting Gonzalo's information and accidentally get Shungo's. So auto increment is there to just prevent things like that from happening. We're going to want a name, which is going to be text, and we don't want it to be nullable, which means please give us a value. Just to show you some other data types you can do, you could say like email, which can be a character of length 50, so we can set limits on how long we want the strings to be and stuff like that. Notice that we do have commas in between these. Those are very important. SQL syntax will get mad at you if you don't have the commas. And it's really annoying to debug when we get to the code. That said, we don't need a comma for the very last one, but we do need a semicolon after the parentheses. So cool, we have a user table. We can check that we've made it by typing .tables, and voila, user is there. If we want, we can even look at information about it. We can say pragma, which I have no clue what that means, but I think it says something about running a command. And then table info, which is the command we want to run on the user table. Wow, it's an ID, name, and email, and it's all the data types we wanted. Perfect. So let's try adding something to it. If you all remember, the command for adding is insert into user. And then we want to say what the columns are. So we insert into name and email values of Rahi and rm834 at cornell.edu. And now we can try seeing if that was there. Who remembers the command to get something? Say it out loud, I don't know. Oh, come on. Oops. Select, thank you, whoever said that. You're amazing. Okay, so select star from user. Yay, I'm there. Let's add some other people in. Let's add Gonzalo in. So that's Gonzalo. Haha, I don't know his net ID. And now if we select from user, cool, Gonzalo is there. We can try doing some more funky select statements. So I could do like select name from user if for some reason all I wanted was the name. That works. You can do other columns too. So I could do like name, email, and that works. We could use some where statements. We could do where ID equals 1. Where statements actually take in Boolean expressions. So you could say where ID equals 1 and name equals Rahi. That totally works. You could do ID equals 1 or name equals Gonzalo, and that should give us both of us. So yeah, normal order of operations for Boolean expressions applies. You can Google that if you're wondering. We could try updating. So we could say update user set email equal, hey Gonzalo, what's your net ID? GG387 at cornell.edu, where ID equals 2, because we want to get Gonzalo. And now, voila, his email has been updated. Now let's decide we don't like Gonzalo. So delete star from user where ID equals 2. Oops. You're right, delete from user where ID equals 2, my bad. Cool. And now, he is no longer there. If we finally decide, you know what, we're done with this, we don't need the table anymore, we can just write drop table user, and all of a sudden, we no longer have tables. So that's just kind of the quick intro to SQL before I get into the code. Cool, so let's do that then. That should probably be bigger. Hopefully that's big enough. Okay, quick thing. Here is a singleton function. It makes it so that when you pass in a class to it, if you then try calling what it returns, it will always give you the same object instance. This is because, say, we have a connection to a database. We don't really want to have multiple connections to that database flying around. That's a little dangerous. If you've noticed, when you try opening a file in multiple places on your computer, it doesn't like it. If you try editing a file in multiple places, it gets mad at you and says this file is already in use. Same idea, but we have to kind of do it ourselves. It's just not a great idea to have multiple database connections flying around. So we're going to be using the singleton class. If you, here, database driver equals singleton database driver. Yay. And now it is thoroughly hidden away so that when people try importing this file, they are only ever able to access this one object instance of singleton. If y'all are really curious about how this code works, we've added a little Google link there that y'all can feel free to go to. That's not the subject of this demo. Cool. So here's the database driver function. This is what we're really going to be going after. So in our initialization, oh, you know what? I need to import SQLite 3. Because this is a new dependency we've added to your requirements.txt this time. Cool. So now we're going to define a new variable, our con variable, which is short for connection. We're going to set it equal to SQLite3.connect. The first parameter is going to be the file name we want to have our database stored in. So, let's go with a simple tasks example, tasks.db. And then here I'm just going to write check same thread equals false. This is just important to say, hey, we don't want other processes accessing this. Sorry. It's not super relevant to this class to have that kind of functionality, so just know that for the sake of this class, always have check same thread equals false. It's another one of those things that if you're curious, you can dive into the documentation or make a Campus Fire post about it, and we will be more than happy to answer your questions. Cool. By the way, is this too big? I'm noticing that I can't see the whole line, but that can go away. Cool. And then we're going to use one of my favorite programming tricks and write self.create task table. That should be plural. And just pretend we have a function that we don't have and let future selves write it later. Later is now. Self.create tasks table. It just takes in self, and this time we get to actually run SQL commands. So this is what this connection variable was for. It lets us, really run SQL commands or execute SQL commands as it is. Self.con.execute. And now here's the janky part. When we want to run SQL commands, we gotta put them in strings. So if y'all don't know how multi-line strings work in Python, it's 3 quotes for a multi-line string. Cool. While we are at it, I have, for those of you that use VS Code, I have an extension that I highly recommend. So let's go to the extensions tab for those of you that are in VS Code. String highlight, where'd it go? Well, looks like it disappeared on me. Found it. Highlight string code. When you're using SQL for this assignment, I really recommend this extension. Let me show you what it does. I'm going to disable it really fast. So if I write create table tasks, right? It's just kind of hard to figure out if we accidentally mistyped something, right? But if I enable it, now we have syntax highlighting within our strings for SQL. I don't know, I think it's cool. Anyways, so create table tasks, and now we have to follow the normal SQL syntax to say what's in it. So ID integer primary key, primary key. Guess what? Auto increment. Y'all are probably not going to have that auto completion that I have. That's a separate thing I have installed called Kite. So don't worry about that. So in an ID, we're going to want a description for what the task is. That can be text, not null. And then we probably want to know whether the task is done or not, right? So that can be a Boolean, not null. Fun fact, SQLite doesn't actually have Booleans in it. So if you tell it Boolean, it's going to internally represent that as an integer 0 or 1. This is something we're going to have to deal with later. For now, don't forget the semicolon. If you do forget the semicolon, it's going to give you errors, and it's going to be really annoying about it. These like SQL errors in these strings are one of the worst things to debug that I've ever had to deal with. They get better in a lecture or two, but for now, I'm sorry. Cool. Now the problem with this is sometimes this execution command can fail. So we're just going to want to surround this in a try-catch block. So that's accept exception as e, print e. Cool. And now we've created our table. That looks like a working function to me, but I guess I'll find out when we run it. All right, let's try and get tasks, right? So let's do def get tasks from our table. That'll just take in self. This time we're going to run a different SQL command. So let's let's execute something on our connection. This time we can just select star from tasks, semicolon. We're going to want to store that in something. And the name for this variable you might find a little weird at first. We're going to call it a cursor. You can kind of think of this as, imagine you're in Microsoft Excel, right? And you have your cursor. Us selecting everything is kind of like moving our cursor around and like highlighting everything, right? It's kind of that idea of a cursor is how we're interacting with our database. So cursor to self.con.execute. But, you know, when you do highlight all of that, you're getting a bunch of rows that you've highlighted, right? When you copy and paste it, it's kind of hard to parse through. And if we try just JSON dumping that, it's definitely not going to know what to do with it. So let's kind of make it a little bit more friendly and turn it into a dictionary. So for row in cursor, we can iterate over it, which is nice. Let's just make an empty tasks variable, and we'll just append each row as a task to it. So tasks.append some dictionary, where ID is the first element in the row, description is the second element in the row, and done is the third element in the row, 0 indexed. This order came from this order, 0, 1, 2, bump, bump, bump. It's always going to be the order that you kind of assign these things in. So that's fine. Now, cool. Return tasks. Cool. So that should be fine, except for that one little snag that I mentioned earlier, which is Booleans in SQLite are fake. So when this returns row 2, that's going to be a 0 or a 1, and we don't want to return a 0 or a 1. We want to return a true or a false. So let's just do some handy Python casting. Bool. Boop. Cool. So now that function looks good to me. We can go over to our app.py, go down to our getTasks function, except no, we can't. Forgot that I have to import it. Let's go to there. Import db, and then capital DB equals db.database driver. That's going to be that singleton database driver. Cool. So now, if I do return, you know what? Let's make our lives a little bit easier. If you noticed in last homework and in last demo, we were returning a lot of like JSON.dumps status code. That's annoying. Let's abstract it. So, oops. let's create a function, success response, that takes in some response body and a status code. And we can default that to 200, right? Because it's a success response. And that's going to return json.jumps body, comma, status code, right? Pretty much exactly what we did last time, but now we have a function that handily deals with it for us. Similarly, we will have a failure response, which takes in an error message and a status code that can default to 404. And we'll just return json.dumps error status code. But good? Nice. So now we can finally go back down here and say return success response of tasks db.get tasks from the table. Simple as that. Now, in our get tasks function, it's so much easier. We just say, hey, just get the tasks from the database. We already wrote this. Cool. So now, you know what? Let's run this and just make sure that things are working as we think they are. So if I go into the terminal, I think, no, this is the terminal. Cool. So now if I quit, clear. So I have to make the virtual environment first. I haven't done that yet. So for me, it's py-m because Windows. That'll take a couple seconds. Cool. And now pip install -r requirements.txt. That'll install all the things we need. And now py-app.py. Well, at the very least, no syntax errors. That's a good sign. So now let's try postman. Let's just try doing a GET request to localhost 5000/tasks. Yay, it's empty. So far, no syntax errors. Beautiful. Cool. So if we go back to the code, let's try writing code to create a task. So this time it'll be def create task. I'm just going to do create task. I'm going to delete that here too, actually. Oops. Just because I think it looks prettier this way. But what information do we need to create a task? We need the description of the task, and we need whether it's done or not, right? This time I'm going to do something a little bit different, and you'll see why once we get to the return statement. So this time I'm going to say cursor equals self.con.cursor. Right, so I'm just kind of extracting out that cursor. And fun fact, self.con.execute is really just shorthand for self.con.cursor.execute. Just kind of abstracts that away for you, syntactic sugar. But yeah, so now we're going to do cursor.execute. Oops. Insert into tasks. Oh, we need the values. So we're going to insert into description and done, right? Values. But wait, we are in a string right now. If I go off and turn off this handy syntax highlighting, this is really just a string. How are we supposed to get these values into this string? Well, the SQLite library does a funky thing for us. It says, hey, in the string, give me some question marks, and that's where I'm going to realize you need to inject code. So we want to inject these two question mark values. And then we get to give it description and done in a tuple. So a tuple is just this kind of single object that contains all of these things. It's slightly different than a list. If you'll notice, it has these parentheses. But yeah, so we're saying, hey, replace those question marks with these values in this order. And the question marks, in turn, are going to go into a description and done to fill those in, right? Cool. Now, we've edited our database, but if you go back to the Excel file analogy, when you edit like a sheet in Excel, you have to save the sheet, right? We have to do the same thing here. So we're going to do self.con.commit to say, hey, save our changes to the database. I forgot a semicolon. Cool. And now this is where it comes to the part where I got the cursor, the reason that I wanted to get it. We're going to do a little funky trick here where we return cursor.lastRowID. Because when we create a task, we want some way of knowing where that task is in the database, right? Because, on PA1, when you created a task, you had to return that task to the user. We could, in this create task, do a select statement, but it kind of feels like it makes more sense to separate that out to a separate function. So instead, we're going to return the ID of the task we just created, which should be the last row in the database, and then we can do a select thing later. Cool. So speaking of that select thing, let's see if we can get that done. 7k def get task by ID. Self has to take in an ID, right? And this time we're going to do the same thing we did in the other one. Self.con.execute select star from tasks where ID equals. This time we have to inject the ID in, so it's ID equals question mark. Now here's a weird thing, just a kind of quirk of SQLite 3. We have to put ID comma here. And the reason for that is just as a kind of typing thing, SQLite is expecting a tuple here. So it's going to try calling tuple functions to split it up. If we didn't have this little comma here, these parentheses would go away and it would think we just passed in the ID. So we need the little comma there to say, hey, this is a tuple that only has one element in it, but we promise it's a tuple. Just get the only thing out of it that you need. Otherwise, we'd get some strange errors. Similarly to, I keep forgetting semicolons. Y'all should call me out on that. And an E. Cool. Similarly to the other getTasks function, this time we've taken our cursor and we've kind of highlighted over what we hope is a single row, but this command has no way of knowing that there's only one thing with ID equals whatever we pass in, right? There might be 0. For all it knows, there might be a billion. We, as the database designers, are ensuring that there is at most one of these things. But this command thinks that there could be a bunch of them. So just like in the previous case, we have to say for row in cursor, even though we know that there's only one row. And then return, this time, since we know we only have one, ID row 0, description row 1, done, bool row 2. And let's say there is nothing with this ID in the database. I deleted Gonzalo out of the database. We're just going to return none so that we have returned something. Cool. All right. So let's go try adding that to the create task function. So that's going to be, well, first, body equals request.data. We're going to want the description. So the description is going to be body.getDescription. And then done is just going to default to false, right? So this time task ID, because remember, when we created the task, we're returning the ID. So that's going to be create task. And while I'm at it, I should change that. Is going to be that. And we know we passed in the description and then false, because it's going to start off false. Now we can return a success response of db.getTaskById, task ID, 201. Oops, sorry, 201. Right, and this time we have to override the status code because it's a creation, and we want them to know that it's a 201, which is a good job, you made something status code. Okay, so let's try that. Let's head back over to Postman. Let's create a task. So Jack, the current backend subteam lead, really likes Grease 2 for some reason. He's managed to make me watch it twice, and I really want him to stop. So let's just add that to our to-do list. That's unfortunate. Did the server stop running? Yeah, looks like I had a syntax error somewhere. But I fixed the syntax error somewhere along the line. So now let's go back to Postman and try running this again. Bytes object has no attribute yet. Where is that coming from? Body.get description. Is it not request.data? Can you check the demo? It is request.data, right? Oh, that's weird. Request.values. Oh, sorry. JSON.loads. Bad. Cool. That should fix that. Okay. Now let's... Oh, sorry. We are over time, but I do think that with the stuff you've learned so far and with the question mark stuff, you do know most of the things that you should need to do PA2. If you need the SQL syntax, it's, you know, in the lecture slides. If you're confused about how to implement this stuff, it's all really the same paradigm as what I've done so far. I'll, you know, take a couple more minutes to finish this, but if you're worried, if you're short on time, if you want sleep, you've learned most of what you need to know today, or pretty much all of what you need to know, and this is really just cleaning up. So no worries if you all need to leave early. Go for it.
This will be recorded, and I'll also be outside if anyone has any questions.
Cool. Yeah. So this time, when we try sending the request, it works. And done is false, ID is 1, thank you. And the description works. So now if we go back to the database, all that's really left to do is updating and deleting task, right? Because get task we've pretty much already done. We'll just do task equals db.get task by ID, get task by ID, task ID, and then if task is none, we're going to return a failure response, right? 404 of task, or that's not how it works. Otherwise, we're going to return a success response of the task. Cool. So update and delete are going to function pretty similarly. Because we're over time, I'm not going to bother implementing that in the actual routes, but I will go for that in the database, just so you'll get an idea of what we're doing. So def update task, and this time we're going to take in description done. So we're going to execute again. Update, and then the name of the table for the update syntax. Set description equal to a question mark, and then done equal to a question mark. Where, I should probably pass in the ID too, shouldn't I? ID equals question mark, semicolon. And now we have to match the order of these question marks. So even though task ID was the first thing that I put into this function, it has to be the last thing that goes in the tuple. So it's going to be description, done, task ID. One kind of cautionary thing, the way I've set up this function, if you try kind of writing the route and you're just passing in whatever the body.get for description and done is, if they only want to update the description, you're going to automatically screw something up, because body.get done is going to return none. You're going to try passing that into this function, and it's going to give you an error because done is non-nullable. So when you're kind of parsing the route, you should fill in this value with whatever it originally was. So you could do a get task by ID to get the previous values. Now we're going to have to commit that, right? Because we made a change. So whenever you do a write operation, you should commit that. We don't need to return anything here. And then finally, delete task, self, task ID. This one is pretty simple. It's just self.con.execute, delete from tasks where ID equals question mark, then task ID. Semicolon. And self.con.commit. Yeah, so that's pretty much all of the relevant functions, I think. If anyone has any questions, feel free to hit me up. But yeah.
Is this due next week?
Yeah, so the assignment for PA2 is going to be due on Tuesday.
Tuesday.
Yes, Tuesday at midnight. PA1, as Gonzalo mentioned, there is an extension until Saturday at midnight. And yeah, for every assignment, there's going to be a permanent extension for up to 60% credit. By 60%, that kind of doesn't include extra credit. So what we're going to do is we're going to take what your grade would have been and then multiply it by 0.6. So if you like got over 10 points because you did extra credit, you could get over 6 points by turning it in late if you do the extra credit. So it's a pretty kind of simple, just multiply by 0.6 what you would have gotten. Yeah, that's pretty much it for today. Thank you all for coming. See you all next week. Hope that was helpful. Oh yeah, for sure. This one. 1 second. Let me stop recording. Yeah.